sign in if you haven't already. tinyurl.com/MLAB fall 17 info, and we'll be started real shortly. Thanks.
Sure, can start now. You can also start now.
All right, let's just start now. All right, everyone. Thank you all for coming here. This is the Machine Learning at Berkeley info session. This is working, right? Yeah, this is working. Thank you all for coming to the Machine Learning at Berkeley info session. I'm Brenton Chu. I'm the president of MLAB, and I'm really glad to see you all here. First, I want to start off with introducing some of our exec team. This does work, right?
How are you using interface?
I don't think you're focused on it.
There you go.
There we go. Okay, awesome. So as I said before, I'm Brenton, right there in the center. And so there's Franklin over there. He's our VP of External Affairs. Piyush, who is our VP of Projects. Olivia, who is our VP of Internal Affairs. Riley, who is our VP of Research. And Phil, who is our VP of Finance. So next I want to actually pass this off to Phil and Riley to give a little bit of talk about what machine learning is.
Hey everyone, really excited to be here to talk about machine learning. I love it. So I want to start out with a comparison between programming and machine learning. Many of you have a good idea of the basic components of a video game like Doom. If you were to build Doom, you want to make sure that the player doesn't fall through the ground. You want to make sure that player stops when they hit a wall and hits targets when they aim and shoot. Wow,
that's too dark.
It's really dark. Okay.
You guys see? Cool, then fine.
Cool. So each of these details are pretty straightforward once you are able to grasp how the game engine works. However, what if I asked you to build a bot that plays the game itself? You can scan through the pixels and try to pick out shapes that maybe corresponds to an enemy. But this is really complicated, especially in a 3D world like the same one that Doom is set in. It's because these shapes of these enemies may change at any different perspective that you may have. Now, don't even get me started on developing a strategy to play the game itself. You can imagine that this process will quickly get complicated. With traditional programming, we'd have to come up with thousands of edge cases, leading to huge amounts of code bloat and lots of developer time spent building a bot that, at the best, will be subpar to humans. Instead, what if we tried to make an algorithm that solves these problems by trial and error, instead of requiring us to engineer each piece of logic? That's where machine learning comes in. We can use machine learning to teach a bot how to play Doom by having it run multiple trials, failing on many different strategies until it finally finds a strategy that works, like the strategy that this Doom bot found at the very end. It's almost impossible to distinguish this strategy from the strategy that an expert Doom player might have, because this bot is playing as well. The Doom bot is only one of the many different applications where machine learning thrives across many different fields in recent years.
Hey guys, so we're all here because we've been impacted in some way by machine learning. And in one of those ways, in the past year, you've probably heard about the development of AlphaGo. And that is a feat by researchers of building a program that was able to beat the Go world champion. So think about how significant this is. Before last year, the strategy game Go was largely thought of as a task that could only be beat by using human ingenuity and intuition. So this is really quite a breakthrough.
Not only is machine learning great at solving a bunch of different games, but it's also really good at managing human tasks like translation. Several years ago, before deep learning was really impacting the industry, Google Translate was basically building a simple model that translated phrases one at a time in between different languages. So in this case, for our first character up there in Chinese, we'd probably directly translate it to knowledge. And that would create a very, very bad and also comical translation that many of you may have tried out before. More recently, Google Translate was able to use neural networks to completely understand a sentence, as you can see at the top here, and then use that understanding to then decode this understanding into English so that the output sentence is much more coherent and the translation is thus much better. Machine learning will also be a crucial backbone in the software that powers self-driving cars.
So how do self-driving cars actually work? Applying deep neural networks to the field of computer vision has fundamentally changed the field, and largely powers self-driving cars. And these same models can be used to perform object tracking and object recognition, even in videos. Machine learning has also changed the field of natural language processing. For example, we can cluster words to capture the underlying linguistic relationships between them. So that means that we can perform math on words. For example, things that we can do include woman minus man equals queen minus king. I can't emphasize enough how significant this is. In natural language processing, never before have we been able to work with meanings of words rather than simply the statistics that describe them.
We can go further with machine learning and actually, instead of just finding patterns, we can actually exploit their pattern finding abilities to generate things. So in this particular case, we have an example of an artistic style transfer. So this method uses a neural network to extract the high-level features of the cat on the top left, the style on the bottom left, and then combine them into this beautiful piece of artwork on the right. I actually applied this technique in a project for MLAB, where I took the style on the left and the video on the right here and ran style transfer. All right, and here's the result. Pretty cool, right? Now I'll pass this on to Olivia, who will tell you all about who we are at MLAB.
Hey guys, so my name is Olivia, and I'm the Vice President of Internal Affairs, and I want to tell you a little bit more about what is MLAB. So here at MLAB, we have a guiding vision, and we want to foster a vibrant machine learning community where driven and passionate individuals can collaborate and really thrive to reach new boundaries in machine learning. So how exactly do we do this? Well, we have 3 core tenets: education, experience, and empowerment. So what exactly do these all mean? So the first one we have is education, and that is really important to us. We realize that everyone starts from somewhere. I know it might seem like it, but we weren't all born spouting out information about neural networks. So we want to give all of you guys as many resources as possible to actually learn more about machine learning. And the way we do this is through, our things like our blog, we have workshops, and we have our decals. And we're going to talk a little bit more about those later on, so just hold off. The next one we have is experience. So once you have this education, how can you actually use this and apply it in the real world, whether it be in an industry or academic setting? So we want to give you that chance to get those opportunities to actually get that experience. The last one is empowerment. This one's pretty important to us. We really want to create a hub of students that feel connected to not only their peers, but faculty advisors and industry leaders to realize that they are able to change the world and go out and push the boundaries of machine learning. So let's talk a little bit about the machine learning scene at Berkeley right now. So a lot of you might know there's some introductory data science courses, you might be reading things online, so that might have sparked your interest in machine learning. But to get there to your intro to ML class at Berkeley, which is CS 189, there's kind of a big gap. And then once you have taken some of those more advanced courses, such as CS 189, 294s, Data Science 100, again, there's another gap. Like, how do you actually apply this theory that you're learning in class to real-world scenarios? And that's what MLAB is here to do. We really want to bridge these gaps and allow students to really take that step and take that initiative, take the next step further. So like I said, the first core tenet that we really want to talk about is education. And this is super, super important to us. So one of the broadest ways we do this and try and target as many people as possible is our MLAB blog. And this blog's actually reached over 150,000 people so far. So I think we're doing a pretty good job. And this we want to reach as many people as possible and make machine learning also as accessible as possible. So we actually have a crash course on machine learning, and it requires limited math background experience. And we're really trying to distill these high-level concepts and be able to teach anyone who has initiative sit down for 20 minutes and read. So I highly suggest you guys take a look and read over that maybe a little bit later if you are interested. The next thing we do is workshops, and this is to reach anyone in the UC Berkeley community. So all of these workshops are open to any of you guys, no matter your level of experience. And we do a bunch of cool different workshops. For example, we bring in a ton of speakers from different industries. We bring research people. And a lot of our MLAB members actually go up and give their own presentations, giving you a little taste of maybe different fields. So for example, intro to computer vision or intro to natural language processing. So whether or not you have a lot of experience, you're able to go and take a look into these fields. Our last thing that I want to talk about a little bit more about is our decals. And so for many of you, you might want to take the next step and take more initiative and actually have something more structured. And so we actually have 2 decals we're offering this semester. So we have our data science decal and our deep learning decal. So for some of you who might not have as much machine learning background, or you're just kind of interested, you may be taking data 8 or you've taken 61A and you kind of want to take the next step further, I'd really suggest the data science decal. It really teaches you the fundamentals of data science for machine learning and allows you to apply really like core concepts and techniques and learn how to do it in a project setting. And a lot of things I've actually learned in the data science decal in the past have actually been used later on in industry. So it's pretty cool and you actually get pretty in depth. The next one we have is our deep learning decal. And this is for someone who's maybe taken CS 189 or has some previous ML knowledge and they really want to take it a step further and go deeper. And so this decal is actually specifically focused on deep learning, and it's pretty cool because you get to really take, cutting edge research and distill it and learn these really cool concepts. So the class, how that one is structured is 50% lecture. So you're gonna be learning things every week. You're gonna have an hour of lecture and then an hour of a reading group where you're actually taking the newest papers and actually learning to distill these really cool concepts and take something away from that. So we really suggest you guys check these out. They're pretty awesome, and it really gives you a way to take an initiative and take 4 to 6 hours a week on your own and with their decals to actually learn more. So now I want to pass it off to Piyush, who's going to tell you a little bit more about how you can take this education and really gain experience in industry research.
Hi everyone, I'm Piyush. I do projects. And so I'm going to talk to you guys about how MLAB takes its members and gives them relevant experience in the real world, both in terms of doing exploratory research and in terms of applying machine learning to real world problems that companies and practitioners are going to face on a day-to-day basis. So our projects are kind of the backbone of what MLAB does as a club. It's kind of where most of our members are going to do most of their work. It's kind of how we actually do machine learning. And so we can kind of roughly partition our projects into 2 categories. So we have industry projects and we have research projects. So as the names kind of indicate, industry projects essentially are kind of, they're within the context of an industry project, a member is going to be working with a company one-on-one in kind of a consultant client kind of capacity. And essentially you'll be on a team and you'll be working one-on-one with a data science team or a high-level executive at these companies. And you're going to be applying machine learning to solve a well-defined kind of encapsulated applied machine learning problems. So you're going to be applying machine learning. That means writing code, designing algorithms, data processing, data manipulation, and applying existing literature and techniques and algorithms such as neural nets to actually deliver a result, actually find patterns in data, and finally build a product that delivers some kind of concrete, tangible result that benefits the client and actually solves a problem that the company is going to face in their actual pipeline. And then on the other end of the spectrum, we have research projects, which kind of deviate from this idea of applying existing machine learning and rather try to push the boundary of what the theoretical side of machine learning actually is. So on a research project, you're going to be doing a lot of exploratory work. You're going to be trying to take existing machine learning literature on the cutting edge of research and the state of the art and synthesize that into new ideas and build on top of them. So you're going to be writing papers, you're going to be publishing research, you're going to be doing a lot of math and proving results. You're going to be running experiments, and ultimately the goal here is to get published and kind of make some headway in the boundary of machine learning on the theoretical side. So kind of the reason that we do all this is we want to kind of connect our members to the real world, both in terms of problems they can solve and companies and practitioners and experts that they can learn from. So that's kind of the motivation behind our projects. We want to give them exposure solving these problems and connect them with real world industry leaders. So on the screen here, you can see a sample of some of the companies that we've worked with in either capacity, such as projects or tech talks or recruiting, whatever it is. We kind of have connected with these companies in multiple ways. But no matter what it is, as you can see, we do our best to work with a diverse set of companies in multiple kind of niches on the supply chain in many different spaces and diverse sectors. So we're not limited to just tech companies. We're not limited to just companies that specialize in machine learning. We have worked with that sort of company before, but we've also worked with companies that don't know anything about machine learning and just kind of, maybe they're not even tech companies. They just want to see how they can apply ML into their pipeline. We've worked with companies that are in very tangential spaces like Medicare or something. So it's just kind of goes to show how ubiquitous a machine learning is, how much you can apply it, and how it's touching absolutely every aspect of our economy and every sector in the market today. So as I mentioned earlier, industry projects they kind of serve to apply machine learning to complex problems that companies face. And to give you an idea of what this actually kind of means, I'm going to show you guys a demo on the GitHub project. So a few semesters ago, we worked with GitHub, and kind of the basis of this project was every time code is pushed to their repo, they run a programming language classifier. But the issue is because this code is run so frequently and so often, and because it hinges on, or so many different aspects of GitHub's internal backend hinge on this code, it needs to be very accurate, it needs to be very fast. And although this problem seems easy by just looking at headers, there's actually a lot of nuances and edge cases that you have to consider. So this is kind of a good case for machine learning because you have so much data. It's kind of not clear how to approach it with conventional techniques. And so kind of what the team did on this side, on this project, was to apply LSTM RNNs to build an ensemble model they could use to classify programming languages. What you're seeing on the screen here is, well, what you saw on the screen here is essentially the project running the model backwards. So they actually took the latent patterns that, okay. So they took the patterns that the model had learned and internalized and actually ran it backwards and used it to generate code. So as you can see, it's more or less gibberish, which is kind of okay. But at the same time, you can see it still learns some of the latent structures and kind of patterns in how humans code. And so that's kind of interesting how you can take this kind of discriminatory classifier and run it backwards to produce generative kind of techniques. And on the other end, we have research. So to kind of give you guys a sense of how a research project functions, I'm going to give you another demo on one of our oldest projects called OpenBrain. So as I mentioned above, the objective of research projects isn't necessarily to build a product or solve a tangible problem for a company. Rather, you're going to try to work on the theoretical underpinnings of the field as a whole. You're going to try to advance the boundary of our knowledge of machine learning. So this clip right here illustrates some of the work done on the OpenBrain project. And kind of the idea behind OpenBrain is if you guys have heard anything about neural nets, which I know are kind of a major buzzword, but the kind of a major shortcoming with vanilla neural nets is that they learn through backpropagation, which kind of requires you to go layer by layer backwards and propagate these error signals one by one, update weights one layer at a time, which is very slow and simply not conducive to real-time online learning. So the idea behind OpenBrain is to kind of try to take this learning process and have it work by having each neuron in the net only process its local neighborhoods. And in so doing, you can get this kind of asynchronous, highly distributed kind of way of learning, just like the brain does, which is a lot more conducive to online learning. It's a lot more inspired by biology and kind of the way the mammalian brain works, which is where neural nets very loosely come from in the first place. And so ideally, we can see that maybe this will actually kind of revolutionize or at least advance the way that neural nets learn, or train rather, in the literature today. And lastly, I want to show you guys a project on called the Unity project. And so the reason I want to bring this up is I want to kind of make a clarification, which was although I kind of described this kind of delineation between industry and research projects, it's a lot better to think of that line as kind of a blurry, a blurry line rather than like a sharp delineation or sharp kind of chasm. And the reason I say this is, although industry projects kind of solve real-world problems and research projects do research and explore, there is a heavy area of overlap between the two that this project demonstrates. Many industry projects do, in fact, have significant exploratory theoretical sides, and conversely, many research projects do end up having very direct applications to the real world and to industry. And so on the Unity project, it was an industry project in which we worked with Unity, the kind of game engine company. And although that was an industry project that we worked on, like a specific video game to build a specific model to solve their problem, it ended up using a lot of very exploratory techniques in deep reinforcement learning and behavioral cloning, and ended up taking these techniques and applying them in very novel ways to the video game. And so what we ended up getting was this agent that was actually learning. It's the red agent, right? You'll see it. And so and we ended up getting this thing to learn how to play this game on its own. As you can see in the beginning, it sucks, but it gets better over time, which is the whole idea behind machine learning. And so, yeah, that's another really cool application that I wanted to show you guys to illustrate how a lot of times these two kind of projects, these two realms of projects do intersect pretty heavily. And so, yeah, I hope that clarifies a lot of the questions that you guys had about projects. If you guys want to learn more, talk to me or Riley about projects at the end. But for now, I want to hand it off to Franklin to talk more about how kind of the different ways that MLAB tries to empower its members.
Hey guys, I'm Franklin. Yeah, so so far you've seen a whole bunch about education and how we're trying to teach our members as well as the greater community. You've seen about how we are gaining experience both in industry as well as in research. And also, we want to empower all of you, kind of like what Olivia said earlier, to really do something with all this. And we think that really one of the best ways to do that is to bring people together. So not only will you be working with other peers who are interested in machine learning and who also want to further the field, we will bring in, professors and other faculty who have devoted their careers to moving the field forward. And also, we will connect all of you with industry leaders who, help teach us entrepreneurship and really how to apply all this in a novel manner, and how we can take the theory and the math and the code and actually apply it in industry and make something substantial out of it that, maybe it's being sold for money, maybe you're just trying to make the world a better place, maybe you're just exploring, but one way or another, we think that people coming together is really how we're going to, make the biggest gains and learn the most and really change the UC Berkeley community in the most substantial way through machine learning. All right, and a huge part of that, of course, is the club itself and the people in the club. Because when it comes down to it, that's the people that you're doing all the things with, and that's who you're gonna be relating with and working with, and maybe spending some long nights with, working on various machine learning algorithms or studying for CS 189 or whatever. And really, if you bring a large group of like-minded, ambitious engineers and mathematicians and computer scientists and statisticians who are interested in the same thing together, and you just put them in a big room and give them a whole bunch of things to talk about and things to learn, then interesting things are going to happen. And in addition to that, we have a whole bunch of social events and fun things. Of course, it can't all be just work. So we have one awesome retreat every semester. That's the middle picture you see there, as well as the bottom right picture. We go on hikes in the fire trails. We take company visits, like the bottom left corner there. There's just lots of little adventures that we can take together, and we do take together to try to have some fun while we're doing this, and really to bring everyone closer together in the club. Because hey, when you're friends with the people that you're working with, we think that inevitably you're gonna work more effectively and produce something better. And the next question that inevitably always comes up is, okay, I've heard about it, how do I get involved? So there are actually a whole bunch of ways to get involved, and these have pretty much all been mentioned at one point or another, but I just want to go over them one more time. So, if you're just getting started in programming, maybe you're taking the 16 series or the 61 series, maybe some of the earlier data classes, then we think the data science decal is right for you. It's a great way to, looking at coding in Python and fundamental machine learning algorithms, stat algorithms, and really just a good way to get your feet wet into machine learning and data processing. And now if you are a bit more advanced, maybe you've taken CS 189, maybe you have some side projects and a bit of research, then you can look into the deep learning decal. Olivia talked a bit more about this, about how it's going to be divided up into both a reading group as well as a lecture. And it's for students who want to, go to the next level and learn about deep learning, which is just absolutely revolutionizing the field and changing the world in so many just fascinating ways. And if you are at that level and you think that you are ready to, take the next step, you want to put in more time, you want to make a larger commitment, then we would encourage you to apply to be an MLAB member. And that comes with a whole bunch of things like internal resources and a lot of the club events that I talked about before. But of course, it is a significant time commitment. And we expect very high performance from our club members, but we will do our absolute best to help you get there. And then for everyone, really, we have lots of public events, and we just want to help educate everyone as much as possible. We want to really work on creating this vibrant machine learning community, and this is one of the really important ways of doing that. We have tech talks. We bring in companies, like they send employees that they're paying here just to tell us about machine learning, just so that we can learn and see how it's used in industry. And then we have workshops. We put time into creating educational demos that will teach you various things, either new tools or fundamentals or algorithms or new models, things like that. So I would highly encourage you to take advantage of those if you have the opportunity to do so. And the next question that everyone always asks is, okay, what's the thing that you guys look for? But the reality is there is not one single thing. Every application that we get, we review holistically. There are so many different roles within MLAB. We have project team members. We have people who have to be amazing at coding to put it all together. We need the mathematical gurus who can really take a look into the theory, and the people who are PMs and can really organize a team and can put together the club strategy, the vision to take us to the next level down the road. There is really a whole suite of skills that could be present in any amazing MLAB member, and a big thing that we'll look for is fit into the club, and how can you help us and how can we help you. Oh, I'm still going. So just one last thing for me to say here before I pass it off is, touch back on that blog once again. So as I was saying, we want to teach everyone as much as possible so that we can help, get people into machine learning and really show people how amazing this is and really get you started running in the right direction. And the blog is a great place to do that. So you can find that at ml.berkeley.edu/blog. Not too tough to remember. So I would encourage you to all check that out. And now I'm going to pass it off to Brenton, who will close things up here.
All right. So one last thing before we conclude. I want to talk a little bit about logistics and timeline details. And so to apply for either of the two decals or as an MLAB member, that's all. The link for all of that is actually right on our website, ml.berkeley.edu. If you go to that website, it's on 3 big buttons right on the front page. It says apply to either the decals or apply for MLAB membership. One detail I want to actually mention for the application is that if you do apply for the MLAB membership and still want to be considered to be enrolled in one of the decals, there is a section there during the application that lets you choose that. You don't have to fill in the decal application separately if you are applying as an MLAB member. And so the deadline for all 3 applications is this Friday, September 1st. It's going to be at 11:59 p.m. The decals, the applications do take a little bit of time. There are some, short answer questions that we do want you to put some time and thought into. We are definitely looking into, a big part of what we look into is the interest and your kind of how much you are interested in applying and everything. And so we do want to just make sure you don't, at 11:59 p.m. try to quickly hammer things out. And for the MLAB membership applications, we will be having interviews for a select subset of the applicants. And those will be conducted on Sunday and Monday, the weekend right after. And the decision for the decals and MLAB membership will all be released by Tuesday. And so I want to thank you all for coming over and listening to our info session. And we will have officers and other executive members stay afterwards. If you have any questions, you can come up and talk to us about that. And remember to apply. The deadline is on Friday. And for those of you who also came in a bit late, if you could sign in at the bottom, I have the link right there, MLAB Fall 17 Info. That'd be great. All right, thank you all for coming.
Nice. That was a good time.
Thank you for coming.
I was thinking about that all the time too.
So Chris,
I didn't know you're in this club.
I'm Alan.
I'm the president.
Yeah, that's really cool. Yeah, I think my schedule's a little bit heavy this semester. I'd probably like do this next semester.
Okay.
That's really cool.
Hey.
Sorry?
You want to do deep learning?
Can you spell that?
We can go back and edit it.
Okay, alright.
Did you try to do that?
Hey, actually, that's a really cool question. So, I'm a senior. I haven't taken 189 yet. So, I'm very interested
Yeah, you can do that.
So, I guess, if I don't have 189, doing actual
we'll see a
membership.
duplicate.
So, I mean, we would, for in terms of the membership or the deep learning accounts, it's like 189 for if you've done like other ML stuff, like you work on your own ML projects, but also you would also take that. So it's just we're looking for some form of previous ML experience. For those if you don't have any previous ML experience, then I would probably recommend the account. So that's 1 year.
I was in the deep reinforcement
we're not. Yeah, yeah. Yeah, so like the data science decal. Being a senior, would I be too advanced for that, or is it still what I get?
There will be some by Professor Review and Chelsea Finney's there.
But we'll quickly from there on to the actual the data science.
Yeah, because I saw some of the
I don't
Zoom
think
example you
so.
guys
I don't
put on.
think
I did an example of the deep reinforcement bootcamp.
he's involved.
We did an example of policy gradients and stuff that was like kind of like similar to that. And so I was just curious. One about the deep reinforcement we did, but also two about the Doom. Did you guys do the Doom example?
No, that was we just got that video.
Oh, okay, cool.
Yeah, that one came out of CMU. Sorry.
I've completed some courses